gravity.
Okay, so let's
Electric
talk
field
about
for your
this.
gravity.
By the way, I have this up on YouTube if you guys want to watch how I work this. So,
Friction.
so start with this big idea. You have the magnetic field and you have X's. So the two most important words are constant speed. So that means all of the forces have to add up to zero. So if the current's going, so let's figure out the direction of the current. So as it's pulled to the right, what are you seeing more of?
More X's.
You're seeing more X's. So therefore you need to make O's. So what's going to be the current in this section to make O's over there? Up, right? So the current is going to be moving up. So if I wrap my hand like this, I'm going to be making dots on that side. Everybody cool with that? Now you use the right hand rule the second time. Now I know that the current is going up, the magnetic field, the external magnetic field is going in. My fingers point to the left. So the force from the magnetic field is going to be pointing to the left. You're pulling it to the right. Which direction is your frictional force going to act?
Opposing motion.
To the left. So you have two things that you're working against. The force friction and the magnetic force. Okay? Two things. Okay? Now, start with verb. Okay? So you want to figure out the current. Well, if you solve for I,
Is it really?
that's V over R. But you're not given voltage. But what do you have?
Believe.
Oh, you have believe. And you also have what?
Oh.
Okay, not.
The resistance. Okay, which is pretty small, 3 ohms. So if you do all this, you get a current of 0.25 amps. Okay? Cool with that. Now, on B, calculate the magnitude of the force required to pull the string at a constant speed. So that's going to be the sum of two things, your force friction and the force from the magnetic field. So, remember, mu times force normal equals your force friction. So you got to go old school with that one. So you do that, and it has a mass of whatever it is, what's the mass of it? 0.22 kilograms times 0.2. So your force friction works out in the name of time to be 0.4312 newtons. Now, how are you going to get the force from the magnetic portion of it?
Q, no, Bill, what is that?
Bill?
Bill. Okay? Now you want to use Bill because there's a reason that you found that current.
Same thing.
Okay? There's a reason that you found that current. So this part is going to be Bill. Now, on the length, listen to me very carefully. On the length part, only use that portion, okay? Don't use the horizontal portion. Only use that 0.52 meters, okay? Only use the 0.52 meters. So, you add all that together, you're going to get, so that's the force from the friction. The Bill portion of it works out to be 0.104. And if you add those together, you get 0.535 newtons. Okay? So that's the total force that you would have to apply to pull this thing at a constant speed. Now, C, it says calculate the energy dissipated in the resistor in 2 seconds, which means you've got to find the power. So one option is that you could pivot up, okay? So, or if you wanted to, this kind of gets a little bit Peace Corps-esque, you could use I believe, because of the fact that your voltage is going to be that magnetic field times your length times your velocity. So that if you do all that math, you get 0.187 watts. But that's watts, which is in joules per second. And you've got 2 seconds, so you multiply that by 2, so you get a total of 0.38 joules. So that's the main part that you need to know. So there's that. On the question with the wires, so let me just kind of give you those answers if you want to work that. So your answer to A is 5.2 times 10 to the negative 4th Tesla. Part B1 is 106 amps. Part B2 is that to the right is the correct answer. Remember with wires, you have wires with currents. Do likes repel or do likes attract?
Track.
Likes attract. Keep that in mind. Likes attract.
That's the one thing I know. I need like 10 questions about that.
Amber, can we just get
wires.
just 10 questions of 2
You
wires
just
have
like
Yeah.
the same
you just like
current?
track,
What
or
happens?
just like-
Yes.
That's the main things. If you can do that, that's as far as I would go on this test. So let me give you a hint as you prepare for the test. Keep track when you're on the test of what's protons, what's electrons. Be absolutely solid with the right hand.
I'm gonna need a reminder every few minutes.
Huh?
Every few minutes I'll need a reminder. Look at your proton.
Play with the doom
Just,
music.
just like stick.
Because literally, that's where the test goes south. It's like, oh man, I didn't pay attention to that was an electron. Because that completely screws up everything else.
We make only protons.
Just,
No left-hand rules.
or should I just like stick my head in the door just like once every 5 minutes? Hey, is it an electron or a proton?
There you go. That's valid.
No, you
All
also
right,
do it with
Andy,
the
stop.
music
You have a
before
camera.
that.